Hello everyone, I am Preeti from Sri Venkateshwara College of Engineering, Department of Computer Science and Engineering, Cyber Security. Today I want to discuss about Newton's forward and backward interpolation. Introduction for Newton's forward and backward interpolation are Newton's forward and backward interpolations are numerical methods used for approximating values of a function between known data point. These methods are based on the principles of polynomial interpolation, which involves fitting a polynomial curve to a set of data points. Newton's interpolation techniques are widely used in various fields such as engineering, physics, and computer science. Newton's forward interpolation. Newton's forward interpolation means it is used to estimate the value of a function at a point that lies between two known data points. It involves constructing a forward differences table using the data. Newton's forward interpolation is used to estimate the value of a function at a point beyond the last known data point. It uses a forward differences table to calculate the coefficients of the interpolating polynomial. The forward differences table is constructed by taking the differences of a consecutive data points in the given data set. Formula for Newton's forward interpolation are P of x equals to f of x naught plus x minus x naught f of x naught comma x1 plus x minus x naught x minus x1 f of x naught comma x1 comma x2 plus so on. Arrange the given data points in ascending order of x values. Calculate the forward difference table by defining the differences between consecutive y values. Compute the divided differences by using the formula. Newton's backward interpolation. Newton's backward interpolation means it is used to estimate the value of a function at a point preceding the first known data point. Similar to forward interpolation, backward interpolation also uses a backward differences table to calculate the coefficients of the interpolating polynomial. The backward differences table is constructed by taking the differences of a consecutive data points in reverse order. Formula for Newton's backward interpolation. P of x equals to f of xn plus x minus xn f of xn comma xn minus 1 plus x minus xn minus 1 plus so on. Arrange the given data points in descending order of x values. Calculate the backward difference table by finding the differences between consecutive y-axis. Compute the divided difference using the backward difference formula. Advantages for Newton's forward and backward interpolation. Newton's interpolation method are relatively simple to implement and understand. Newton's forward and backward interpolation are relatively simple and easy to implement. They provide accurate approximation when the data points are evenly spaced. These methods can be used to interpolate values for functions that are not easily differentiable. These techniques can provide accurate approximation of the function values within the given data range. Newton's interpolation methods can be used for both evenly and unevenly spaced data points. Limitations of Newton's forward and backward interpolation. Newton's forward and backward interpolation may not accurate results for unevenly spaced data points. They can produce large errors if the function being interpolated is highly auxiliary. Newton's interpolation techniques can become component applications for Newton's forward and backward interpolation. Newton's interpolation methods are commonly used in numerical analysis, physics, engineering, and computer graphics. They are used to estimate values in scientific and engineering calculations. These methods are also used in curve fitting and data smoothing techniques. Newton's interpolation methods are commonly used in numerical analysis to solve problems involving interpolation and approximation. These techniques find applications in fields such as physics, engineering, finance, computers, graphics, and data analysis. Newton's interpolation methods are particularly useful in situations where regular sampling of data is not possible or particular. Example for Newton's backward interpolation. We want to estimate the value of f of 0.5 using Newton's backward interpolation. By constructing the backward differences table and applying the interpolating polynomial formula, we can find the approximation. Comparison of Newton's forward and backward interpolation. Forward interpolation is used when the desired point lies between the first few data points. Backward interpolation is used when the desired point lies between the last few data points. Both methods follow a similar approach but differ in the direction of interpolation. Newton's forward interpolation is used when estimating values beyond the last known data points, while backward interpolation is used for values preceding the first known data point. Both methods construct different tables but in different directions. The choice between forward and backward interpolation depends on the direction of approximation needed. Conclusion for Newton's forward and backward interpolation are Newton's forward and backward interpolations are powerful techniques for approximating values between known data points. They provide a simple and effective way to estimate values in scientific and engineering applications. Understanding these methods is essential for solving interpolation problems efficiently. Newton's forward and backward interpolation are numerical methods used for approximating values for a function between known data points. These techniques involve constructing differences tables and using interpolating polynomials to estimate function values. Forward interpolation is used for values beyond the last known data point, while backward interpolation is used for values preceding the first known data point. Thank you so much for watching my video.